Okay, hello and welcome to today's section in further maths. Today we'll be talking about the Pascal's triangle. Pascal's triangle. But before we proceed, I would like us to do a quick review of our previous lesson. Okay, welcome back. Now, you know, in mathematics, whenever smaller number is being given to us to expand, for example, if I give you a question like x plus y raised to the power 2, all you need to do is just x plus y, x plus y. You now start x times x gives you x squared plus x times y, xy, plus y times x, xy, plus y times y, y squared. Now with this you now have x squared plus 2xy plus y squared. So this is the expansion. This becomes the expansion of this. It's a bit simple. Now if I go further into extending it to x plus y raised to power 3, now we have x plus y, and x plus y. So let's deal with these two first. Now in dealing with these two, we just did that and we got x squared plus 2xy plus y squared times x plus y. So if we start multiplying this, x times x squared is x cubed, x times this is plus 2x squared y plus xy squared. Then y times this is plus yx squared. Y times this again is plus 2xy squared. Then this plus y cube. Now I want us to see if there is any term that is related. There's xy, there's xy, and there's yx squared. We have yx squared. So this becomes x cubed plus 2x and yx squares 3x squared y. So I'm done with this. X squared y. Then plus this will give us another 3xy squared. That's for these two. Then plus y cubed. So if you expand x plus y raised to the power 3, you have x cubed plus 3x squared y plus 3xy squared plus y cubed. Now if you watch, the more we keep expanding it, by the time we now change it to x plus y raised to power 5, we might start using up to 5-6 pages just to perform our expansion. And remember, this might not just be the question. This might just be part of the question. Maybe while solving you got to this point, you want to expand it before you proceed, and you just find yourself here. Now in seeing things like this, a certain a mathematician just came up with an idea. John Pascal came up with an idea of creating the Pascal's triangle. Now the function of the Pascal triangle is to help you expand any form of expansion, or to carry out any form of expansion without passing through all these tedious processes. Now we'll go into details of how Pascal's triangle was being created and designed. So we are moving further. Now we'll be dealing with the Pascal triangle is just a shape that looks like this: 1, 1, and 1. One rule about the Pascal triangle is that it starts with 1 and ends with 1. Now it's just an addition matrix. that was used in creating the Pascal's triangle. Now you have here 1, you start it with 1. 1 plus 1 is 2. There is nothing again to add, you end it with 1. Then you come to the third line. Each line you create, you leave the previous lines and concentrate on the line you created. Now before you start doing anything, you add 1. You start adding everything. 1 plus 2 is 3. 2 plus 1 is 3. There's nothing to add again, you end it with 1. Now write your 1. Now add 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Nothing to add again. You bring down your 1 here. You place another 1 again. 1 plus 4 is 5. 4 plus 6 is 10. And 6 plus 4 is still 10 again. 4 plus 1 is 5. And there's nothing to add again. You end it with 1. Now, so we talk about power. Power of 0, 1, 2, 3, 4, 5, and so on. Now let's do a test run of what we just did. Now let's use this. This is our power of 3. If you now have x plus y raised to power 3, instead of you to embark on this type of long journey that we did here before arriving at this, the best thing you have to do, remember the coefficient. This 1 stands for the first and this other one stands for the last. That's why it begins with 1 and ends with 1, because the one at the beginning and the one at the end is being owned by each of these separately, but each of these numbers in the middle, any number in the middle, is owned by when they are joined together. So let's look at how it goes. Now if we have this is the third, for the third power, you now write it like this: x plus, remember this x is for this one, then 3 should be xy, put the two numbers together, plus 3 again should be xy, since it's not 1 but this is 1, so you write only plus y. That is it. Now remember, what we are dealing with is raised to power 3. You start sharing the 3 like from here. 3 for x, 2 and 1, you leave it, and that of y is from here. 3, 2, you stop. That's where you stop. Then you add the coefficient. That's all. We have 1 here, you don't write 1. 3 here, you put it. 3 here, you put it, and 1 here is already here. Now if you expand x plus y raised to power 3, this is your answer. So if I happen to give you x plus y raised to the power 5 to expand for me, now this is for 3, this line is for 1, 2, 3, 4, 5, so this is the line for 5. Now let's apply together in expanding this. Now remember the rule, the first one is owned by x and the last one is owned by y. Let's start. First one, x owns the first x, you place it here. X, that's the x, plus this is 5, so you write x and y together. X, y, plus, but don't add anything. This is 10, you put x and y together, plus this is 10 again, you put x and y together, plus this is 5, you put x and y together, the last one is 1, that is, it belongs to y. Okay, now let's start. This is raised to power 5, so y start taking it from here. 5, 4, 3, 2 and 1, you stop. Now that of x goes this way. 5, 4, 3, 2 and 1, you leave it there, you don't put the 1. Now, what are the coefficients that have been attached? The first x is 1, you don't write it. What is a 5? You put it here. This is 10, you put it here. This is another 10, you put it here. This is 5, you put it here. Now, if you should expand, if you go into expanding x plus y raised to power 5, this will definitely be your answer. So Pascal did a lot of work in trying to see that everything about this is simplified for our own use. Now we can use this to solve several equations. I can use Pascal's triangle example 3. Use Pascal's triangle to solve the value of 1.01 raised to power 4. Now, you know 1.01 is the same thing as 1 plus 0.01 raised to power 4. Now, let's apply a Pascal triangle. Raised to power 4. In the fourth lane, we have 1, 4, 6, 4, 1. Have 1, 4, 6, 4, 1 in the fourth lane. So, of the Pascal triangle. So, we now start. 1 raised to power 4 is the first, plus the next one should be 4, 0.01. The next one is plus 6, 0.01 all squared, plus 4, 0.01 raised to power 3, and plus 0.01 raised to power 4. Now you can see that this 0.01 is the second value here. It started from 4, 3, 2, 1. Why this one is 1? It started from here. 1 is the same 1, 1, and 1. So your answer becomes 1 plus 0.04 plus 0.0006 plus 0.00004 plus 0.000 this. So this is simply equal to 1.04060,401, and it can be approximated to 1.04060. That is in 5 decimal places. Now we've gotten the value of this using Pascal triangle. I would like to say a very big thank you for making out time, for coming up to this lesson. But I would like you to take up the test that will be coming up soon on the screen. Always endeavor to contact or to revisit this particular site for clarification on the subject matter. Thank you. See you in our next class.